Now we shall move to the last speaker of this session, Dr. Mohamed El Gabry, Associate Professor of Seismology at Riyadh, Egypt. He will talk about disaster risk for cultural heritage sites, insights from Egypt. The floor is yours, Mohamed.
Thank you. Thank you, Professor Gad. I hope you hear me well now.
The volume is a little low.
Is it okay like that?
Yes, no.
Okay, my presentation, I will try to be short, and I know you are exhausted after this long day. I will talk about disaster risk mitigation in Cairo, especially. In disaster mitigation, we always go to the doctor to look to ourselves and be in a good shape. The same thing we have to do for building. As you see in this cartoon, also buildings can suffer from diseases. And for us, diseases, in order to diagnose this, we have to have structural health monitoring systems. To have a structural health monitoring system that monitors the building and its state and its ability to face any disaster like earthquakes, flooding, and other risks. In Cairo, it is a famous city for the 1,000 minaret, and minarets are very sensitive buildings. They are a tall building, they are old, and they are affected by shakes. In 19 and we have the minarets has different styles and shapes and dating back to different times. In 1992, an earthquake has shaken Cairo and left about 560 casualties. More than 10,000 were homeless, and the losses were estimated to be $350 billion. Many of the ancient buildings were affected by this, especially in historic Cairo, and minarets was one of the victims of this earthquake. This has triggered many restoration process in the whole city and declaring it under the UNESCO. And but for us, it was important to know how we are restoring and how we can optimize the restoration process, especially for minarets. In this photograph, it depicts or this drawing 1860, and you can see a lot of minarets in Cairo has lost its endings, and this mainly because of many earthquakes were hit Cairo, like 1847 earthquake. We have several earthquakes in the historical catalog. It's important to understand how these earthquakes has affected the buildings, the minarets, and in order to do this, we are having a large campaign to measure the structural response of the different minarets in Cairo. In this slide, you can see all the minarets of the citadel of Saladin in Cairo, and you have the two minarets of Muhammad Ali, the minarets of Sulaiman al-Khadim or Sariyat al-Jabal, and the two minarets of Qalawun. And we conducted measuring the ambient noise and the spectrum. To be short, these are the natural periods or the natural oscillation of the building. After the measurements, we were measuring from the base to the top of the minarets. Here, the minarets was about 30-meter height, and you can see here the natural period, which is around 1.2 hertz. This is the other minarets. As you can see, it's the same building, but that minarets has different height and different style. So we conducted the natural period 1.7 to 2.1. Here in Sulaiman Khadim, at the front one, it was between 1.2 and 1.5, the natural period. And here in Muhammad Ali Mosque, you can see that the natural period was much longer, which 0.4 to zero point 0.5 hertz. And as far as you are going up, it's the building is higher, the natural period is longer. This is the second minaret. It's the same minaret in Muhammad Ali. As you can see, we have different ranges of frequencies, which is ranging from zero point 0.4 to 2.1 hertz, which is resembled by this square. And in this curves, you can see the expected acceleration due to earthquake in Cairo. And it's very interesting that in longer period, as you can see here, you have the spectrum is higher in amplitude. And this is because of some far field effects, far field earthquake, which can affect Cairo and trigger longer period where we have the minarets is behind is staying here. It's important to us to go into more detail numerical modeling. I will give here one example for numerical modeling for one of the mosques, which is under restoration now, Tatar al-Hijaziyya. We have conducted, this is a minaret itself. It has lost already its top. We have conducted measurement in the minaret. We have built a 3D model, and we have built also a 2D model for the ground to measure the effect of the amplification of the soil itself. Here is a building due to the gravitational load, which is very normal without any earthquake. Okay, the stresses is okay. We have no problem, and we don't expect any high stress. And when we apply earthquake scenarios, we applied different scenario, 1992 earthquake, and also we applied the worst case scenarios. And here is the response of the minaret due to lateral and horizontal forces. And as you can see here, the maximum forces are triggered in this area, the area just below the balcony, the first balcony and the second balcony. So if we are intervening here and we having intervention for restoration, these areas are the most affected areas to be intervened. To go to the conclusion, of course, this work is under processing and we are working still, but it's important to better understand the modeling of the minarets and the buildings and how they are behaving under the earthquakes, and how we can use this information into the restoration process, because this can save a lot of money, a lot of effort, and they can be more realistic in mitigating the effect of earthquakes. That's all. I hope I was not, I was short and was not too boring.